Hi everyone, Gary and Krishna here. In this video, we'll be demonstrating VirtualWire in the Adaptive Cloud Fabric. VirtualWire is a NetVisor technology that enables admins to create a virtualized patch panel out of an open networking switch or fabric. Essentially, VirtualWires are links between physical ports, either in the same switch or on a switch in another cluster in the fabric. All packets, including control protocols and even CRC errors, are transmitted across the link. In a fabric, VirtualWire brings several benefits to the table. For example, link creation is automated. Pick your endports, execute one command, and the Adaptive Cloud Fabric will build a path for you. Once created, the link's endports are synchronized. If one goes down, the other does as well. No traffic black holes. Additionally, the Adaptive Cloud Fabric enables centralized management, eliminating the need to configure devices one by one, allowing you to configure the entire VirtualWire fabric from a single node. The topology we'll be using in today's demo is a two-spine, two-leaf fabric with two test devices attached. Our objective will be to create two paths between VW test 1 and VW test 2. The first link we'll create between leaf 1 port 37 and leaf 2 port 9, shown here in violet. The second link will be between leaf 1 port 39 and leaf 2 port 10, shown here in blue. This demo is broken into 4 steps. First, when test 1 and test 2 are physically connected to the VirtualWire fabric, and we run an LLDP show command, no neighbors are seen. This is by design as the switch is in VirtualWire mode. Second, we'll configure the two VirtualWire links we described on the prior slide. Third, we'll show that at this point the test 1 switch will see the test 2 switch as a neighbor. And fourth, we'll take down a port on one of the test switches and show that, as expected, the corresponding port on the other end of the VirtualWire goes down as well. Now before we start, we've included a slide of the commands used in this video at the end, so no need to try to keep track of them. Let's get started. So in this display, Krishna is SSH into 3 switches. In the left and right columns, we have VW test 1 and VW test 2, which are the switches we want to connect with VirtualWire. In the center column is VW spine 1, which is in the VirtualWire fabric. Now, starting in the center column, Krishna will issue the fabric node show command. Here we can see the 2 spines and the 2 leaves we described in our topology slide. Now he'll issue the switch mode show command to verify that all 4 switches are in VirtualWire mode. For our first step, we'll issue the port show command simultaneously on the test devices, so we can see that test 1 is connected to leaf 1 and test 2 is connected to leaf 2. Next, Krishna will enter the LLDP show command to run at 5-second intervals. At this point, the test switches don't show any LLDP neighbors yet. Now for our second step, Krishna will run the command to create an association between leaf 1 port 37 and leaf 2 port 9. Done. Now note, the path of the bidirectional link that was automatically created is displayed by switch and port number. Now at this point, step 3 is already accomplished. If you look at our test switches in the left and right columns, we can see that leaf 1 and leaf 2 started seeing each other as LLDP neighbors as soon as the first link was created. And now we'll run the second command to create the association between leaf 1 port 39 and leaf 2 port 10. For the sake of brevity, we'll be accelerating the video a little bit. Done. By running the port show command, we can see that the links are up and view an assortment of information about the link itself. Okay, time for step 4. Krishna will run the port config modify command to disable port 55 on test 1. And on the right, he'll run the port phi show command. As expected, the corresponding port 12 on the other side of the link is now down. So that's it for our demo, folks. As promised, here's a list of the commands used in this video. For more how-to videos and documentation, please refer to the resources section of the Pluribus Network's website. The QR code on the right will take you there. Thanks for watching.